Hello, hello. Sally here. So, some interesting things have come up where people are. Oh, I'm sorry. Hold on one second. I have to mute myself. Okay, there we go. Sorry about that. So, anyway, what I'm getting to is in typical trigonometry introduction courses, there's this problem that's stated to students, which is given the shadow length of an object on the ground, can we determine its height? And this is how people are introduced to trig and how we can use trigonometric functions to determine the height of objects based on their shadow length. It's a pretty classic, standard introductory problem. So what I decided to do is show a real world example of that using a baseball bat. And we're just going to go through it right now. All I did was go out and take some pictures, and now we're going to talk about those pictures. So let's look at this real quick. This is basically my setup. I have a baseball bat standing up in the driveway, and it is casting a shadow. Um, and what we want to do is determine the height of this bat, which we already know, so we'll be able to verify our calculation, against this shadow right here. And one thing to keep in mind is that all shadows have an umbra and a penumbra. So what we really want to know is the height of this outside edge of this baseball bat, which you also have to keep in mind is half a barrel width closer to my measurement, because my measurement is actually taken at the center of the bat right here. So we'll have to keep that in mind when we make our calculation. And we want to see where the umbra ends up. Okay, because the umbra is going to be directly in line with the sun, so we'll be able to get an elevation from sun calc of the sun at the time of this photograph. The photograph was taken at 5:25, I believe. Let me verify that in my photos real quick. Let me see here. Actually, took a screenshot. Let me pull up my photos real quick. We get all the necessary information. So we'll be talking about this measurement here. Yeah, so it was taken at 5:25. All right, which I will happily share right here. Okay, there we go. Taken at 5:25 today. Okay. So based on that, based on the 5:25, we need to get some data from the internet, from SunCalc. SunCalc. And set this up for 1725. Oh wait, it's on UTC plus 2. Let's move this first to my location. Go away. Okay. All right, about there. And we'll go to 5:25 here. So 17, come on. 17? Why won't it let me do 17? 17, there we go. Can I type 25 here? Oh, that's so bizarre. 1725. I moved my location again. About right here. It's good enough. I've still got some take time. There we go. Okay. Okay, so the altitude or the angle of the sun going across the bat is 15.11 degrees. So that means, let's go to GeoGebra real quick and let's diagram this. Geometry. Just draw some lines. Okay, so assuming the bat is BC, and let's put an angle on there to make this clear. BAC is going to be 15. Whoops. No, I need to use this. BAC is going to be 15.1 based on the altitude that we just got from SunCalc. I'm going to have to zoom in a little bit to get to 15.1. Okay. So the tangent of 15.1 will be the opposite over adjacent towards Old Alabama. Tangent of 15.1 is going to be opposite, which is BC, the length of BC, over the length of AC. So what's the length of AC? Let's look at our photographs. Okay, so the length of AC, see the one I took at 525. It's that one. This one. Okay. So the length, we're looking for the umbra, which I would say is about right here, which is, roughly 123 and a half. Okay, so 123 and a half. So let's go back to GeoGebra. Can I add a label here? Should be able to, right? Add a label. Settings. Caption. 123.5. Okay. There we go. And so what we want to find is this. Here, we'll make this X. We have 123.5 inches, 15.1 degrees was the altitude of the sun. All right, so what we need to do is set up a formula, which will be, can I just add a plain label here? That would be great. Here we go. It will be tan of 15.1. I'm going to type it the way I'd put it into Google. Degrees times the length, which we just determined was 123.5, correct? 123.5 less half the diameter of the bat, which is, actually I have a picture of that. This bat has a 2 5/8 inch barrel. Okay, so how would I do that? 123.5 minus 2 plus, well, half of that, so that'd be 5/16. So 1 plus 5/16. That's half the barrel width. Subtract that, and let's make sure that our order of operations is correct. So that right there should give us the answer for the height of the bat, I do believe. Let's type this into Google and see what that answer is. 32.9. All right. So that's pretty close. It's a 33-inch bat. So, some measurement error there involved. But essentially, we were able to calculate within a reasonable error range, 4/100ths, of an inch, the length of the bat based on measuring the umbra. And that is how this problem is solved. It's a basic trig problem. It's used for introductory trig. So, with that in mind, let's look at something interesting. Let's go to Google Earth. And let's go look at a recent objection made by flat earthers about this St. Anne water tower. Now, I'm not going to do the math for flat earthers. This is your homework assignment. And I think you know I'm talking to you because you're the one bringing up the objection. So your homework assignment is to look through this historical data. Oops, just happened there. To look through this historical data of photographs of this tower. We got a whole bunch of photographs of this tower starting in 2004. Okay. And you are able to measure a couple interesting things. I'm going to give you some pointers here, some help for your homework assignment. You're able to measure, basically try and find the center of the base because this is taken at an angle. I think the base is down here somewhere. We're trying, measurement error is okay. We're going to try and find the base, find the length of the shadow, and you'll notice a couple things whenever you make this measurement is that you get one, the map length of the shadow, and two, the heading. Now this heading is actually backwards because I started in the south. If we go from the north, then we can match it up with the sun calc headings or just astronomical azimuth headings. And you can do that. So you'll get a heading like this, 143.46. Now this problem's slightly different because you're going to have to take an extra step. Okay, and that extra step is to come to SunCalc on the date in question. This is the month, day, year format that Google Earth is using there. So that would be April 8th, 2004. And what you're going to want to do is you come over here to SunCalc and let's find our location. Oops. So our location's over here in general. You can find a more precise location. It's the St. Anne water tower. So we need to find St. Anne, which I believe is somewhere around here. Where is it? I think this is St. Anne right here. Yes, there we go. So this is St. Anne Drive. The water tower is about right there. You can get more precise if you'd like. And then what you're going to want to do is select the date here, which would be April. I think I said 8th, right? April 8th, 2004. April 8th, 2004. And then you're going to want to find the time, a day, okay, where the heading, and the heading is the azimuth, where the heading matches the heading that you found in Google Earth here, 143.46. So if we do that, 143.46, and there's going to be some measurement error. 143.47 is fine, close enough. And then that will give you the altitude of the sun on that day when this photograph was taken. So now you should have all the information you need. You have the altitude of the sun, you have the length of the shadow. I think the only other information you might need is the width of the bulb at the top of the water tower. But using all that information, you should be able to do the similar thing that I did and try and determine the height of that water tower. Now, what you will notice is because of the way the thing is shaped like a bulb, it won't always be the same edge or the same part of the circle that's actually casting the shadow, which means that the height will vary a little bit, but you'll be able to find a range that's good enough to give you an idea on just how tall that tower is. And there's a bunch of different shadows you can choose from. You can make a bunch of different measurements, come up with an average. Look, here's a good one. So I'll leave that up to you as a homework assignment, and I'll let somebody else tell me what the average is, what the range is for the heights of this water tower based on measuring the shadow alone using the technique that I just listed. I'm going to give you a hint. It's not 26 meters. So if you can do that, then I might have some respect for you and I might start responding to your comments. Good luck. Everybody have a good day.